Given that the dinosaurs lived for such a long time, today's question really spans a vast stretch of our planet's natural history. The Mesozoic era, the age of the dinosaurs, is further split into three periods: the Triassic, Jurassic, and Cretaceous period. The Jurassic period is generally seen as when dinosaurs were at their strongest and at the peak of their powers. But the first examples of these colossal creatures actually emerged millions of years earlier, in the Middle Triassic. The first dinosaurs arrived then, around 240 million years ago, and, as we know, they grew and spread and evolved from that point until their extinction moment with the asteroid 66 million years ago. In terms of what the world looked like over all that time, it certainly underwent massive change, not least because the age of the dinosaurs overlaps with the breakup of Pangaea. While it's easy to view the world map as it is today and assume that it must have always been like that, we know that it certainly wasn't. And we know that, during the Triassic period, almost all of Earth's land was actually massed together as part of the supercontinent Pangaea. Pangaea spread almost from pole to pole, meaning that you could feasibly walk from the top of the world to the bottom without ever finding your way blocked by water. There were still oceans on Earth, however, and the majority of the Earth's surface was still covered by water. It's just that the ocean wasn't split by smaller continents as it is today. Instead, Pangaea had epic coastlines running north to south on either side, and a massive ocean simply ran all around the globe, from one side to the other. This was the world that the dinosaurs were born into. But by the end of the Cretaceous period, Pangaea had broken up. A map of the world 66 million years ago is still quite different to today's, with Africa much closer to South America, Australia only just beginning to break away from Antarctica, and modern-day India cut off alone in what's now the Indian Ocean. But the shapes of the continents as we recognize them were beginning to form. For the dinosaurs, this of course had an impact. When dinosaurs first emerged, they all essentially lived on the same landmass. There were weather differences and localized conditions across Pangaea, yes, as well as mountain ranges, rivers, and other natural borders. But the first dinosaurs were never quite so cut adrift from each other as the last ones were. By the end of the Cretaceous period, 66 million years ago, there were dinosaur breeds confined to much smaller landmasses than their earliest ancestors had been, with their homes pushed to different regions of the globe thanks to plate tectonics. That said, in terms of pure climate, even at the end of the dinosaurs' reign, researchers believe that most of the world will have been basking in similar climatological conditions. It's generally said that the world was tropical during the time of the dinosaurs. There were certainly desert regions, including across what's now North America, but for the most part, Earth was warm, wet, and lush. Even those places furthest north and south, including what's now Antarctica, were not stacked with ice as they are today. Meanwhile, it's been widely documented in recent years how the air that the dinosaurs breathed was likely much more oxygen-rich too, which is one reason specifically why they were able to grow and thrive in the first place. There are some theories, however, that the climate may well have been changing toward the end of the Cretaceous period, and not for the better from the dinosaurs' point of view. In fact, according to one 2021 study, the changes on Earth just before the asteroid hit might have even meant that the dinosaurs were soon to die out anyway. It's just that the asteroid hurried along the process. So, what's going on? The multi-authored study first appeared in the scientific journal Nature Communications in June 2021, claiming that dinosaur biodiversity declined well before the asteroid impact. The study focuses on 6 dinosaur types, or families, known to have existed up until the asteroid fell, making use of the fossil record to estimate how many of each dinosaur was alive on Earth pre-asteroid 66 million years ago. And, after a lot of number crunching, the bottom line and lead takeaway from the study is that all 6 families were in decline. Some worse than others, but it's thought that the numbers for all of them were falling, all over the world map, and that they had been falling steadily for at least 10 million years before the asteroid. The conclusion that this particular study arrives at, then, is that the dinosaurs may have been going extinct anyway, with or without the asteroid. The next question is why? The leading theory, and one that's referred to within the study itself, points toward the effects of climate change. It's thought that average temperatures on Earth had dropped by the end of the Cretaceous period by almost 8 degrees Celsius. The key thing here is that the dinosaurs were what's known as mesothermic. They weren't quite cold-blooded creatures like most reptiles are, but they weren't warm-blooded like mammals either. Importantly, the mesothermic classification is still debated in the scientific community, but if we do view dinosaurs as mesotherms, then the drop in global temperature is likely to have had a major impact on any dinosaur species' health, as they relied on outside temperatures to properly function. The study also highlights how cascade effects might have been putting pressure on the dinosaur food chain too. This is when a decline in one dinosaur type can trigger a decline in another, its predator, which can cause a decline in another, and so on. Unlike in the Jurassic period, it seems that the dinosaurs and ecosystems alive in the Cretaceous simply weren't as strong. They certainly weren't robust enough to withstand when the asteroid hit, but they may have been dying out anyway. In an alternate world where the asteroid didn't hit, there's no way to definitely say whether they would or wouldn't have survived. History shows us how various species of dinosaur and of other have experienced dwindling numbers before, only to bounce back and restore stability. Perhaps the dinosaurs could have achieved that too, which could well have meant that the rise of mammals would have never taken place, and therefore that we, human beings, would have never emerged either. The breakup of Pangaea would still have continued, and the world map would still have gradually formed into the layouts that we know today. It's just that it would be marked with the dinosaur habitats, rather than human towns and cities. But of course, in the real world, we know that a mass extinction event did take place 66 million years ago, and that, although the effects of it weren't quite so instantaneous to kill off every dinosaur at the precise moment the asteroid hit, the resulting long-term ecological change and disruption was enough to take these creatures to extinction. Up until that time, the dinosaurs had overseen massive change on planet Earth, the breakup of a supercontinent and the formation of several smaller landmasses being the simplest change to visualize. Their typically tropical landscapes were evolving as well though, and according to research, this might have meant that the dinosaurs' days were numbered anyway. A mostly lush and green planet, but one that was going through some major changes too. That's what Earth was like before the dinosaurs.